Hey, good morning, good afternoon, good evening. Hey, Brandon, how are you?
Doing well, Kirk. Thanks for hosting and helping us out today.
Sure.
This morning and this evening to our friends in India.
Absolutely. All right, so
morning,
hello,
Kirk,
everybody.
Brandon.
Hey, we got Sam and Aditiya. Great to see you today. Hey, so
good morning, gentlemen.
Yeah, good morning. Good evening. I'm going to just say Brandon is the lead for Humtown's additive manufacturing effort, and it's his show, so please take it away, Brandon.
All right. Yeah. Thanks everyone for joining, making the time. We tried to pick a time that would, help some of our colleagues here in the U.S. be able to join early. And, we appreciate everybody over in India, taking some time out of your evening to join us. Our two panelists here that we're going to have some great discussion about additive manufacturing, as well as, all the participants, everybody that's joining to learn. So, it's been quite an adventure, stepping out, as a company that's been in business for over 60 years, going from conventional manufacturing to, entering into this 3D space. What we're finding is that the community, although we have a very global, reach, it's a very small community, so joining with people, around the globe, like on our first, perspective on 3D sand printing, meeting with Ricardo Toledo and people in Brazil. We found, through networking and through some really good opportunities, to meet with Aditya and Sam today, to hear a little bit about what is taking place in India, what Humtown can do is, to help build a bridge, for our colleagues here that need to, make castings, overseas. We develop sometimes castings here in the United States, but then that casting design is very robust, and maybe we need to take that overseas, to point of need manufacturing in other countries. So we're going to have some discussion this morning about from Aditya on the Indian 3D printing network. I was on a webinar with him not so long ago, and it was great to talk and have discussion points about what's taking place in the United States as well as in India. And then Sam is going to give us a really nice look at what some foundries are doing in India, utilizing conventional casting, using some additive manufacturing, some subtractive manufacturing, as well as direct metal printing. So have a really good opportunity today to hear about what's going on globally, and really appreciate Sam and Aditya for joining us today. I'm going to try to launch and share my screen here so that we can start with the presentation. All right, everybody should see the welcome screen, and with that, we're going to jump right into a little bit of background about Indian Printing Network, and then Aditya, we'll have you take it away.
Thanks, Brandon, for the introduction, and it's great to be here today with the two of the experts from the foundry industry, Brandon from the US and Mr. Krishna Samaraj from Magna Electro in India. And it's really great to present our perspective as well as the Indian 3D printing network. So spend what we do. Co-founding neutral knowledge sharing and business networking platform for India. Our main goals are to really spread awareness about 3D printing and really catalyze the industry in those areas. So that's our role, and we are technology and agnostic as such. So we are trying to address the whole 3D printing ecosystem. Of course, today we are more talking about the foundry and casting applications where sand, binder jetting, and now maybe direct metal printing becomes plays a role. So to start off, can I request Brandon to move to the next slide? Yeah, so this is something we did in 2019 to kind of understand where the Indian AM industry was, because there was a lot of there was not a lot of clarity in terms of where the Indian 3D printing industry was. So this is just a baseline in terms of we're trying to understand, who are the international brands present, what are the homegrown AM brands and service providers doing. So this is something which we did in 2019. We mapped the market. We created the India AM report, where the market value of the Indian AM industry we estimate to be around $0.6 billion, which is about Indian rupees 4,500 crores. This is again focused more on specifically on 3D printing. So this gives you an idea in terms of what the size is, where what are the brands already present in India. So you see all the leading service provider OEMs and present in India already. So metal 3D printing has been growing steadily for the past 5 years, primarily focused on laser bed, powder bed fusion. Of course, the first sand printer came back in 2000. It was not the current binder jetting technology, but more of the laser sintering of sand, which came back in 2000, where one of the automotive OEMs used it for their casting and foundry applications. And what's happening in India is various applications. So if you're looking at automotive, tooling, dies and molds, jewelry, precision engineering, energy, there has been use cases where 3D printing is used. Obviously, maybe in the initial stages where it's more prototyping for some of the industries. That, for example, the Indian automotive industry uses 3D printing for prototyping very extensively for all the polymer applications. So they're well versed with the technology. Aerospace in the last 2-3 years has been growing pretty fast. There have been now parts which are flying as part of the Indian Air Force and Defense. They have been authorized to fly parts printed in India. So there's a lot of expertise now building on the metal AM side. Medical, of course, is something which is also growing. Maybe not that relevant to today's discussion, but medical 3D printing has been growing steadily as well in India with a lot of titanium implants and pre-surgical models, a lot of work on that side. So this gives you a broad idea in terms of the whole market scenario. With this, I'd like to move on to the next slide, where I'm talking more about the metal AM installed base right now, because that's something interesting in the aerospace, tooling, engineering, automotive, medical, and dental segments. Up to maybe around March 2019, we had about 82 systems across. Most of this is powder bed laser sintering technology. So we have again pretty much most of the brands represented in India across the board, and a lot of work happening in the aerospace tooling side for conformal cooling. Automotive is still is more in the infancy stage, and medical, again, as I mentioned, implants. A lot of dental implants are being printed, exported to Middle East and other countries. So that's an interesting model which has evolved as well. So why I wanted to mention this is with this structure, there's a lot of skill already being developed, to use a 3D printer, design for a 3D printer, which is very important when we come to something like a sand binder jetting, creating a mold, understanding, the orientation, the various aspects of to ensure that the mold can function as it needs to, and ensuring the quality of the part as well. So that's a brief on the metal side. If we could move to the next slide. This is which gives you an application split in India where AM is being used today. So obviously jewelry manufacturing is something which is big in India. So jewelry has been adopted pretty fast. So I think based on our recent estimates, about 80% of the jewelry manufactured in India today, 3D printing plays some role across India. So that's an interesting fact. What I'm trying to say here is that there has been adoption in very conservative areas like jewelry, which is more labor intensive. So jewelry has adopted 3D printing as well. Automotive transport, as I mentioned, is the leading adopter across polymer and metal, followed by tooling and engineering, jewelry, healthcare, dental, consumer products, electronics, education research is about 8%, and followed by government defense and aerospace, which is 6%, and others. So this gives you a breakup in terms of where is 3D printing used today across the Indian market. Moving on, we're just working on understanding the adoption of 3D printing in the foundry and casting application. So it's still not mature as an industry, but yeah, we already have about 10 plus systems across India from most of the service providers here in India. X1, Voxeljet. EOS, of course, is a solitary machine, which is the older sand winder, sand laser sintering technology, which was the one installed in 2000. 60 to 70% systems today are for captive use with OEMs, which are primarily used for their own use for various applications. Material and the binder quality is at par with global standards because most of it is imported, which is similar material which is used in Europe or the US. So the quality of the molds can be consistent with what is required from global standards. Foundries are opening up to adopting new technology. Of course, COVID has played a big role in changing mindsets because there's a lot of need for local supply chains, to future-proof our industry. So foundries are adopting, opening up to new technology. A few of the foundries are also taking up sand binder jetting. Of course, India again has the necessary foundry casting metallurgy expertise available here. So it's all about understanding the business case, providing the right direction, and connecting the right people to make this happen. So I feel India has a big potential here to take advantage of this technology and see, look at advancing our manufacturing capabilities. And again, large engineering and engineering design workforce is available as well, so which can be tweaked or can be utilized to our advantage for the foundry and casting applications in AM. So with that, I'd like to conclude for today's session. I'd like the experts from Magna and Humtown to really take it ahead. But just before that, I'd like to sum up about us. So as I mentioned, Indian 3D Printing Network, we are a neutral knowledge sharing platform acting as a one-point contact for the additive manufacturing industry in India, engaging with the AM community on a constant basis. Part of our services, we started with a trade show back in 2015, which is today India's largest trade show on additive manufacturing. It's called AM Tech, which has been there for about 5 years. And we have had participation from the major brands trying to build a networking platform. We have own a publishing and media platform called AM Chronicle, where we're trying to again build awareness, spread the knowledge to the industry. As you've seen from this slide, we are working on our market research and intelligence to ensure that the right information is available to the industry to take decisions. And Additive Academy is something was born out of the pandemic, which we really developed to see if we can be the bridge between academia and the industry to really create skilling opportunities for everyone. So in a nutshell, that's what we do. And with this, I'd like to hand over to Mr. Krishna Samaraj, who's been one of the foundries who's adopted 3D printing very early in the day and has the expertise right from design to implementation. So with that, I'd like to hand over to you, Mr. Krishna Samaraj.
Thank you, Aditya. Good evening, everyone. Namaste. I'd like to, it is indeed a privilege and pleasure to be participating in this global perspective on sand 3D printing. And I would also like to thank Brandon of Humtown for organizing this as a good global collaborative effort. I would like to just give the audience a brief on our company, Magna Digitech. How it was started and how we got into the 3D printing business and some of the activities we are doing. Basically, Magna Digitech was founded in the year 2006, and we have 15 plus years of successful engineering services for the foundry industry. We specialized in troubleshooting, simulation, casting design, fab to cast, reverse engineering, everything based around the foundry, because we also have a foundry, Magna Electrocasting, which is 25 years old, and that is how we got started. So over the years, we said we were delivering virtual solutions and products to our customers. Now let us give them a physical solution in terms of prototyping. We have about 100 foundries in India and globally who use our engineering services for the foundry. The next slide, please, Brandon. The casting simulation services, we basically use the MagmaSoft, and I would dare to say we are among the top users globally of MagmaSoft, having done more than around 2,000 simulations to date, both for ourselves, for our foundry, as well as our customers, which are other foundries. I'm sure everybody knows here about the advantages and the pros of casting simulation services. The next slide, please, Brandon. Can we go to the next slide, please? Yeah. The prototyping, what we call the prototype express, where the customer needs quick and economically manufactured complex prototypes. The picture you see is of a 6-cylinder head, diesel engine head, which we manufactured right from the solid model to the end product within a matter of 4 weeks. Most of the time was spent on planning and designing. We printed the sand molds and cores, assembled it, and supplied it to the customer, whose collaboration was a Japanese company, and they really appreciated it, and they did not know that India could do it, do this type of development works in such a short time. The next slide, please. The second area where we play and we help with our customers is what we call complexity simplified. That is where a typical application would be in a hydraulic manifold, etc., where complex profile cores are required, and it has to, these are very delicate cores, and they have to be placed without any breakage. Of course, there are many foundries around the world who specialize in this, in hydraulic components, and their expertise. You know, I got 25 years expertise in manufacturing hydraulics. You are a new foundry, you cannot make it. Here, 3D printing broke that belief, because with the 3D printing capability, a foundry which was really not into hydraulic products was able to get into hydraulics. So the history or the large experience of 25 years, etc., was neutralized by this technology. That is of course, we should respect experience and technology, but it allows even other people to come in and break this technology. We can leverage. Next slide, please. These are some of the products which we have printed via binder jet. Our machine is 1.5 meters by 1 meter by 750 mm. Some sample things you're seeing for the 6-cylinder printed turbochargers, impellers, and hydraulic components. The next slide, please. In addition to additive manufacturing, we at Magna, we also do subtractive manufacturing. In other words, we give a customer a sort of a hybrid solution depending on the situation, depending on the products. If the customer wants, it's a very big casting, and customer wants only 1 or 2 pieces, we go via the Furon mold block and we mill the mold. That is the most cost-effective way, and the cores are done through 3D printing. Another hybrid approach would be The cores will be 3D printed and the molds are manufactured in our foundry, either in green sand or furan. If a customer wants, let's say, 25, 30 pieces at a time, that will be the most applicable. So we have a variety of options to choose from full-scale 3D printing to additive and subtractive manufacturing for low volume pieces. And if it is multiple pieces, 30, 40 pieces, or like a beta testing in the field, we do a conventional manufacturing and integrate it with 3D printing. The next slide, please. From these aspects, we have to date, we've started our journey on sand 3D printing in November 2017. And in the last 2 years, we have developed around 200 to 220 products, different products for the Indian customers as well as global customers. We have some customers even in the US for whom we do rapid prototyping. So from there, we said, okay, what is the next step for us? Okay, we have sort of established ourselves. Of course, there's still a lot for us to learn in sand 3D printing. We were looking at what is the next step to go see. From a foundry background, we always talk in terms of pounds or kilos or tons. So we said, okay, let us look at things a little bit differently and go look at direct metal printing. We have chosen to partner with Desktop Metal in the direct printing business, and ours is the first installation in India for direct metal printing. And we are still learning the ropes. We are still learning the ropes. The 3D sand printing and castings was very easy because we had 25 years of experience. People knew us, we knew what a casting was, we knew what the issues were, and our design services, engineering services, really accelerated our business case there. Here, we've got this machine installed. Again, it got hit by the COVID issues, and this machine was installed from November, and we are slowly feeling our way, and we've got a couple of applications for the desktop metal printer. Here are some of the parts, sample parts, which we have printed on this. The big difference here is the physical size, the physical weight of the parts, and the challenge to have customers designed for additive manufacturing. The engineering at our customer side, the challenge is for them to design these parts for this. And for example, we should see that helical gear and pinion in our binder jetting desktop metal machine. They are not solid products. They have a honeycomb structure inside. Our customers are used to solid products. They're saying, hey, this will not work. Why is this weight so much? When I say customers, this is customers in the traditional earth-based industry, not the aviation guys. The traditional earth-based industry where weight doesn't matter much. So that is some challenges which we are looking at. Over time we will get over that challenges. The next slide, please. So the basic in-house technologies we have are the Furan 3D printed machine, printing machines. I'd also like to add here, we also provide completely machined, ready to assemble products, as well as validation. We have a Roma 6-axis absolute arm scanner, a 5-axis machine, and other bigger machines which we have in-house, in our in-house machine shop. The next slide, please. These are our facilities. One is the machine shop and direct metal printing, what you see on the right-hand side, and on the left-hand side is our sand printing plant. They are in the city of Coimbatore. With this, I'd like to thank everyone for their patient hearing, and I turn it over to Brandon to take it forward from here. Thank you, sir.
Sam, thank you. And Aditya, both of you, I think you've really kind of honed in on some of the future, of additive manufacturing. It's interesting. In our last discussion in Brazil, they're still working to get, consolidated effort to get a 3D printer, sand printer in country, to use for multiple foundries. But here, seeing what you've built and the technology that you're growing upon, it's a step. You start with one technology, you take a step, you use another technology, and we always say in additive manufacturing, you have a toolbox, and it's really neat to see all the tools that you guys have in your toolbox to get the end customer what they need. So congratulations on things that you're doing. Thank you for sharing that with some of our colleagues here in the U.S. so that they can see some of the steps that that maybe they can take. But this technology is really enabling what I've found in our role at Humtown. We 3D print parts for foundries. We don't cast parts, but we help a lot of customers put 3D printing pieces of equipment in their facilities. We do consulting, we go in, we help them understand the technology, where to use it. And I can tell you every single time that I teach somebody how to use the technology, almost every time they come back and they're some of our biggest and best customers, in the following years. And that's because I really, truly feel that, there is so much opportunity in the market, not just locally here in the United States, but globally, that, by partnering and working together, I really feel that we're going to go so much further together. So, like I said, I can't thank you both enough, for that. I was just wondering, Sam, one question that kind of came to mind. You have a list of questions. You covered most of them, both of you in your presentations, and I really appreciate that. How many machines are in India, compared to other countries. I think having 10 plus sand printers is really amazing. But are you seeing the opportunity to 3D print direct metal parts to get into your customers' hands quickly, even though they don't have the metallurgical requirements, they don't have any certifications? But is that helpful to get a 3D printed metal part into your customer's hand quickly and then follow up using like 3D sand printing or mold milling hybrid, Sam? Is that something that you've seen?
Brandon, we haven't seen much of that because the direct metal printing, whether it is laser based or binder jetting, whatever, so far it has been only for smaller sized components and what I would call exotic metal. The aerospace type, the light metal applications. Mm-hmm. So is there a demand to immediately print and give direct metal and then convert it into sand? I'm afraid not, because that is a different deal in terms of the scope, in terms of size, in terms of cost, in terms of reproducibility. It is a different. Right. If a customer wants something based out of casting, we can, within a matter of, depending on the queuing, within a matter of a couple of weeks, and how mature the design is. See, most of the time what we face is the designs are not mature.
I think that's a global issue. That's not unique to one part of the globe. Engineering to hold on to a design as long as possible. And we've enabled that, with this technology. So I had to laugh because, we face the same issues. So that's interesting. So So no, thank you for answering that, because that's always a question. I mean, for anybody using additive manufacturing, I heard the other day somebody said, oh, in 5 years, 3D metal printing, direct metal printing is going to replace foundries. And I kind of chuckled to myself and said, if you can find somebody that can 3D print, a brake rotor or an engine block or a cylinder head, for less than, I don't know what I threw out there, $5,000 or $10,000. I said, I show them to me, because, we're talking, huge castings, that weigh, hundreds of pounds. And I said, I don't see that going away in the next 50 years, but I do, salute you in embracing direct metal printing, whether it's using a desktop metals or, as Aditya said, some, laser bed, there are applications for that technology. And in my opinion, I don't think that there's anybody better suited to get into that space than a foundry. You understand metal, you understand metallurgy, you understand, properties, heat treat, sintering, those types of things really fall into the hands of foundries, in conventional processes. So, I don't know, Aditya, if you want to chime in, you're on mute right now, but if you want to chime in on that, and then Sam, if you want to add anything to that. But, from my perspective, I think that foundries are the perfect to take that leap into direct metal printing, not to replace castings, but, to open up your product offering. What do you think about that?
Yeah. Yeah, I agree. I agree about what Mr. Samaraj says, at what level we are, and of course, the 3D printing is one, as you mentioned, it's one of the tools in our toolkit, right? So it's not going to be the toolkit. It could in some of the areas, but if you look at rotating parts, there is still hesitancy to go for AM in terms of qualification and certification at various levels. And of course, as you mentioned, the kind of large parts which you're looking at casting is still, as you said, I think 50 years is something which is take these things to go. It's also important to see if the part is complex enough to really use AM. So I agree with both of you, and on that point, that metal printing is being used for smaller components. Of course, if you look at other areas like medical and stuff, it's directly used for implants, but then that's a different ball game altogether. But in the core manufacturing, it's more on the conformal cooling side, or parts which are complex in design are still being made. So it's still a long way to go for that kind of technology to come in here.
Yeah. And Sam, what do you feel about foundries being, in my opinion, a humble opinion, that foundries are the perfect place to use direct metal printing? What translates from your experience over to direct metal printing?
I think more than technologies, we foundry people need to have a completely new mindset, which is the most difficult thing. From tons and pounds and kgs, we have to move to grams and ounces. From a couple of dollars a castings, we have to move to $1,000 a casting. Most of us foundrymen, even when we started, we were afraid to even go and talk to the customer. How can somebody give $1,000 for such a small product?
Right.
So a big mindset change has to come. And foundries, we are used to dealing in mass production, mass volumes. This is a different mindset. It's not that it cannot be done, but it has to be separate. That is why even in our case, we didn't put it under Magna Electrocastings, which is a foundry. We spun off a small company like a startup, and have the average age here will be about 30 in this company. In my foundry, the average age will be about 50.
Yeah. Very good.
Different.
It's a good.
In the foundry, we talk about months. Here, we talk about days.
Yep.
Well, not yet hours, but it may come to hours.
Yeah. No, I mean, I think that's a great perspective. You know what I mean? There has to be a fun shift in our thinking, before we can just jump in and say we're going to use our expertise in metal to become, a 3D printing expert. That's very good.
Yeah.
Guys, I mean, we could talk for the rest of the night, and I don't want to keep you up all night, but we do have quite a few questions over here in our Q&A. So I'm going to get to some of them. Some of them have been upvoted. You know, the number one question is it possible to receive the PDFs so that people can internalize this? And I'm sure you guys are okay with that. We'll get that presented.
Yeah.
This recording is also going to go out, so anybody but we will provide those in a PDF format, you know, that we can easily email and disseminate against the participants, as long as you guys are okay with that.
Sure, no problem.
And I'll
fine.
actually, you know, Sam, you had a few more supporting slides. I'll actually package your internal complete package with that.
Okay, great.
And then the next question was, is there a leading 3D printing OEM in terms of innovation, efficiency, and adoption to the Indian marketplace? So, you know, both of you, I mean, Sam, you've made some commercial decisions, obviously, on the brand you've went with. So we'll get your perspective first, and then, you know, what have you seen more nationally? So we'll start with Sam on that question.
Can you repeat that question once again, please, Brandon?
Yeah. Yep. Is there a leading 3D printing OEM? So, you know, out of all the printers that you evaluated, is there one that's leading in the terms of innovation, efficiency, and adoption into the Indian marketplace? So that could either be a global one or an Indian manufacturer that you've found.
Okay. In India, as around the globe, it is the German twins who are the leaders for sand printing.
Okay.
The German twins are the leaders in the sand printing technology. Of course, we chose to go with an alternate machine, an alternate supplier for various other reasons, including affordability. But if you basically see, okay, that the sand printing technology is a technology of integration.
Right.
None of the companies around the globe, sand printing equipment suppliers around the globe, manufacture everything. They integrate products. You take right from the printhead or the controller, the printed firing board. Most of it, the computer controls, the pumps, everything is available in the market. That is how good are they at integrating it, and the software presentation. Plus, of course, there's a lot of minute technology in terms of process controls and the droplets. You're looking at so many thousands of drops per square centimeter or square inch. How do we control it? The raw materials in India, if you look at the raw materials, it is the same raw materials. We can't take a chance with the sand, because in India, sand is treated as a mineral, not as a product. Sand is sand. We don't treat it as a product. So what do you mean a specification for a sand? There's nothing like that in India. I'll give you sand. I'll dig it straight out of the lake and give it to you. You do whatever you want.
Gotcha.
So none of us 3D printing companies in India use domestic sand. It is all imported from Europe.
Right.
Same way with the binders and resins.
Okay. And then Aditya, on your perspective, you know, more nationally, maybe, what are you seeing for the leading OEM in terms of innovation, efficiency, and adoption?
Yeah, I think, the sand printing ecosystem is still quite small to really have a difference at a local and a national level. And I would agree with Mr. Samaraj that there is the X1 and Voxeljet are the OEMs which are leading in terms of innovation, efficiency, and adoption. And also, as mentioned, it's all about the integration of how the inkjet technology works with the software and the entire ecosystem. So I feel in sand, it's really I won't see there is a difference between the national and the local implementation of sand 3D printing, at least.
There are no Indian manufacturers or OEMs of 3D sand printers. Is that correct?
Yes, there have been attempts, but there are no
commercially available
at the moment. There are
Yep.
no commercially available systems.
Okay, great.
For sand.
No, thank you, gentlemen, both for your input on that. You know, I mean, and we also agree. You know, I mean, as a company, you know, we have 5 3D sand printers in our facility, and you know, it's very important. You know, all the things that Sam said. You have to make sure that those printers, you know, the integration, piece of equipment is great, and a company can come in and train you on, you know, start up to start down that piece of equipment. But what we find, and the value, you know, that we provide our clients is the light switch to light switch, you know, operations, setup. You know, when you're setting up a cell, you know, you may have X amount of dollars for the printer itself, but you have to really look into, the whole manufacturing process. So that's one. You know, there is a question here about the process flow of 3D sand printing. Unfortunately, we're not going to have time, but you're going to have all the contact information, you know, for myself, Sam, and Aditya. We can definitely go through, and we have slides, supporting slides on the process flow of sand, you know, that we can cover. One last question. We got to wrap up here and start, you know, go out and do a little bit of networking. But how have the universities been involved in AM and helped facilitate its growth in India? And that's a great question. And the reason that personally resonates with Humtown is because due to local universities like Youngstown State University, and then through America Makes, which is very similar to the organization, Aditya, that you run, they networked us, and we basically got our start in 3D sand printing between Youngstown State University as well as University of Northern Iowa. So without those universities, I don't feel that we would be where we are today. So I think that's a great question to end on. So take whoever wants to table that question, but how have the universities been involved in help facilitate the growth of AM in India?
Yeah, I'll take that at a overall level, because it's the sand printing industry itself is too small to talk only about that. But what we've seen is, if you compare it to the US, I guess we are, in terms of the research institutes and the industry working together, maybe we are about 10 years behind in terms of what needs to be done. But that being said, there are AM labs across all the institutes. So if you look at the IITs, which are the leading technical institutes in India, there is research going on materials. There is work going on processes. Recently there has been work across. Recently there was a part for the aerospace for the Indian Air Force, which was qualified locally, where an institute was involved. The Indian Institute of Science in Bangalore is doing a lot of work. They've developed their own technology for E-beam. They're working on that technology. So there is work happening across, but what's happening is now, this year, there is a central policy for additive manufacturing which is coming into place, which was not there for everyone to work in unison towards one goal. So I feel in the next couple of years, everything will kind of integrate and work towards a goal to grow the technology. So there is the Ministry of IT and Electronics, which is coming out with a policy along with creating a national center for additive manufacturing here in India. So I think this will now, in the next couple of years, kind of everything will synergize, and industry will grow pretty fast from here. From talking to everyone, I think there is now, the large industries are now investing, and I'm sure they will invest in research projects as well, which will kind of then result in further adoption. So that would be my take on it at this moment.
Great. No, thank you. And then Sam, what do you see? I know our small company, 50, 60 employees, we reach out to local universities and trade schools. We are the customer of these universities to hire, engineers and technicians. So do you see, from a business standpoint, are you seeing, that you have access to good candidates, or are you growing them in-house? I guess would be kind of the perspective I would want to know from a small to medium-sized business.
See, India reputedly is the second nation after China to graduate engineers. The number of, in terms of numbers. However, there is a kind of dichotomy. Even though we produce the maximum number of engineers in all fields, mechanical, electrical, electronics, software, whatever, the bulk, the best, and the cream, they go to IT industry.
Gotcha.
Okay, where IT industry takes them, even if you're a mechanical engineering graduate, they train you for a year and make you into an IT wizard. So in terms of the challenge for us in general in the manufacturing industry, and more so for smaller companies like us, is attracting the good talent. So we are left to dealing with what we can get.
Okay, that's fair.
Which may not be the best. Whatever we get, we have to deal with them, train them in our own way, and keep them. That is the thing as far as talent goes. But on the other hand, all of our universities, money is not the problem. They have all kinds of equipment. For example, in my city, in Coimbatore, I think we were the second one with the EOS sand printers, the sintering technology, almost 10 years ago.
Wow.
I think what Aditya said, that may be our machine in Coimbatore. And it was put together by an industry association, not an individual company, an industry association. But spending money is the easiest part of a business.
Yep. Keeping it
what
going.
What do you do with that later is the challenge.
Yep. Well, that's
funds are not an issue. Funds are not an issue for our educational institutions.
Okay.
Yeah.
And keeping that talent in the foundry industry to be, part of the problem is trying to entice them to not go to the IT and other fields, but to keep them in the foundry industry can be a challenge.
Yes.
Is that fair?
Yes.
Okay. No, we see the same thing. You know what I mean? A lot of engineers want to go and develop product or and be in other industries, aerospace, and even though the aerospace industry needs casting, sometimes we do have a hard time acquiring that talent as well. But gentlemen, unbelievable. I have 20 other questions here, so luckily for our participant, everybody that came to join, they're going to be able to have all of our contact information. This will be recorded and sent out. I would be prepared to field a lot of questions in the next couple of weeks because this is a great turnout. I think we should definitely do a follow-on to this because I didn't allot enough time for any of us. So maybe I'll get up an extra hour earlier instead of cutting into your evening next time. But
no, perfectly fine.
Yep. So thank you, gentlemen. We are going to be back out to the networking tables. So you'll all be at your respective table. I'll be at mine. Thank you. Once again to everybody that joined us this morning. We ran over a few minutes. Thank you for your patience, your time, all the questions. And I'm sorry we didn't leave enough time to get to all of them. But this is a great session. And look forward to talking to everyone soon. And stay safe, stay healthy, and never stop innovating.
Yep.
Thank you.
Great. Thanks, Brandon, again for great being part of this.
Absolutely.